everyone. So the idea of today's lesson is we're going to be looking at 9A and the focus is going to be on combining what we've been doing with geometric growth and decay. So we're going to put situations together when you're going to need both growth and some form of decay happening in the one relation. Okay? So that's going to be our focus. Now, these kind of relationships are really actually common, and it's not just money types of situations. There are lots of different situations when this kind of combination between growth and decay can be used. So let's start off with an unusual example for you. Imagine that I've got a slow leak in my tyre and I'm losing 2% of the pressure in my tyre each day. And at the end of the week, I stop at the servo and I put 10 pounds of pressure into my tyre, okay? And our focus is on how much pressure am I going to have at the end of each week. So a recurrence to model this might look something like this. So we've got our VO equals 36, which means my car tyre starts off with 36 pounds of pressure in it. Now, remember I said it was losing 2% per day, but over the course of the week, that means it's going to have lost 14%. So remember, we take our 100% and we minus the 14. So Vm plus 1 is equal to 0.86. And then at the end of the week, I'm going to put back 10 pounds of pressure into the tyre. So I'm going to add on the 10. So this represents the decay component, and this represents the addition or the growth component. And I just noticed that I'm missing something in my formula. There should be a Vn there. Okay. So that's how we can combine growth and decay together in this type of situation. Alright, the standard way of writing it is usually VO equals whatever our starting value is, Vm plus 1, so we'll have our rate multiplied by our starting value and plus or minus something. That's the standard format for when we're writing a recurrence relation in this situation. Okay, so here's another example. Imagine I'm a trout fisherman. I do get around a bit, you know. First of all, I've got a problem with my tyre. Now I'm trout fishing. Not a problem. And I own trout ponds. And basically this is a situation, it's trout farming. So we put a certain amount of fish in, and then we're taking it out and selling it to companies so that they can put it on the market for people to buy, so you can have trout for dinner. Okay? So we're going to model this situation. So fish in the fish pond after n months, so Tn, can be modeled using a recurrence relationship. So TO equals 10,000, Tn plus 1 is equal to 1.1 times Tn minus 3,000. Let's just stop and think about what this actually means. So the TO equals 10,000, that's our starting value. So that suggests that we've put 10,000 fish into the pond to start with. So in the pond at the moment, we have 10,000 fish. Now let's look at the first part here. We've got 1.1. So that's being a number bigger than 1, we're talking about growth. So if I've got 10,000 fish in a pond, how am I getting growth? What's going on there that can possibly allow for growth? I'm going to give you a second to think about it. Remember, we're talking about fish, living things. I hope breeding is coming into your head. They're making babies, people. Okay? So roughly 10%. We've got fish breeding and we've got young being produced. And then minus 3,000 means at the end of each month, I go in as the trout farmer and I take 3,000 fish out and I sell them to the market so that people can have trout to eat. Alright, so how many trout am I going to have after 2 months? So TO equals 10,000. So after the first month, I'm going to have 1.1 times the 10,000 minus the 3,000. So I'm going to have 8,000 fish left. Okay? After the second month, I've got 1.1 times 8,000 minus the 3,000. Now I've only got 5,800 left. So after 2 months, there'll be 5,800 trout. If I was a trout farmer and my stocks were going down that quickly, I'd probably need to have a rethink about either my starting value or how much I was taking out each month. So these mathematical models are actually used in real-world situations to help businesses make decisions. Because if this is the analytics, I might have to say, right, well, I'm going to start off with 20,000 fish so that I'm getting more fish to start with, which means I'll get a greater number that breed, and therefore I won't see such a reduction. Or if I'm smart, I'll notice that it's about 10%, and if I take 3,000 out each month, maybe I need to start with 30,000 fish so that the breeding rate equals the rate at which I take them out. But that also depends what my plans for my fishing farm has to do, whether I want the stocks to deplete or whether I want to try and maintain my stocks. But people in situations like this do make decisions about the real world. Okay guys, get on with this exercise, get your questions done. Thanks.